Here's problem 17.8. Calculate the intensity level in decibels of a sound wave that has an intensity of 15 times 10 to the minus 4 watts per meter squared. So we have an intensity of 15 times 10 to the minus 4 watts per meter squared. By definition, the intensity level is equal to 10 times the log, base 10, of our intensity over some reference intensity, which is the intensity at the threshold of hearing. So we have, this is 10 log base 10 of 15 times 10 to the minus 4 divided by 10 to the minus 12. And if we just plug that into our calculator, what do we get? 91.76 decibels, or we could write that as 91.8 decibels. So that would be our decibel level. Let's try an alternate method. Not necessarily better, just an alternate method. So if we were to use this intensity, we would say the intensity level is 10 log 1.5 times 10 to the minus 3 actually over 10 to the minus 12. And because you can separate logs from their products, this is going to be 10 times the log of 1.5 plus 10 times the log of 10 to the minus 3 over 10 to the minus 12. 10 log 1.5 is 1.76 plus 10 times the log of 10 to the 9. I can decrement the 9, bring that down in front, and then the log of 10 is 1. So this actually equals to 1.76 plus 9 times 10, 90, or 91.8 decibels. Not necessarily a shortcut, just a different way of analyzing it in case your calculator has problems. Or, let's try one last way. Our intensity is indeed 1.5 times 10 to the minus 3 watts per meter squared. And if we use the idea that 1 watt per meter squared corresponds to 120 decibels, then if we went down to try to find this intensity, say if we went down to 0.1 watts per meter squared, that would be 110, and then 0.01 would correspond to 100 decibels. Still going down, 0.001 corresponds to 90 decibels. And if we were to go up 1, so we multiply by 1.26, we have 1.26 times 0.001, which is 10 to the minus 3, corresponds to 91 decibels, and multiply by 1.26 again, and we get 1.59 times 10 to the minus 3 is equal to 92 decibels. Not quite a shortcut method in the best form, but just an alternate method of determining the decibel level of that intensity. 92 decibels rounded up.